Okay, we're going to be doing convert sorted array to binary search tree. So you're given an integer array called nums where the elements are sorted in ascending order. Convert it into a height balanced binary search tree. A height balanced binary tree is a binary tree in which the depth of two subtrees of every node never differs by more than one, right? So as you can see here, the depth is at most one, right? It's not more than one. So what we're going to do is we are going to use depth first search, whereby we'll be creating the roots as we go down, right? And then when we reach the end, we return none, and then we return the roots going back up, right? How do we do this? We're going to create a helper to create the tree. And what will the helper take? The helper will take the array, we'll call it array, a starting index and an ending index. Okay? The base case is when start is greater than end, right? So if start is greater than end, right, that means we've gone outside these possible values, right? So anytime we go outside these possible values, we simply return none, right? So if we had come at this position, we'd return none. If we had come at this position or this one, would return none, right? Okay. Then here we are at the, I call it node parts of, let's just call it recursive case. Okay, here we are at the recursive parts. I forget how I term this, but anyways, so at the recursive parts we find a mid, right? So for this array, right, the midpoint of this array will be the first root index. The midpoint of the left side will be this root. The midpoint of this side will be this root, right? So we always find a mid, which will be our root, right? So mid is equal to start plus end divided by 2, right? And then we create our root. And how do we do it? We say root is equal to tree node, and then we initialize our root with a val. So root.val is equal to array at mid. So placing the value at this position into the root, right? So now we recurse left and right, because remember our tree node has a left pointer and a right pointer. It also has a val variable, right? So root.left is equal to helper array start till mid minus 1, and then root.right is equal to helper array mid plus 1 till the end, right? We've already dealt with a mid, so we don't want to use it, right? So this will recursively go to this side, the left side, find the mid, which will be this creator root, then go recursively to the left side, find a mid, create a root, and then reach none, return none, right? Because start and end will have become, start will have become greater than end. So after we've done this, we need to return the root, right? So when we reach the ends here, we need to return these back so that we can stick them into the left side and the right side. Okay, so we simply return root, which is what this helper function returns as well, right? So we return helper nums, we start at 0, we end at length of nums minus 1. And voila, it works. So that is the solution. This is it's an O of n time, because you have to go through every single part of the array, and it's an O of n space complexity solution because of the call stack. Okay, so thank you and bye.